Okay, so you want to own a chip factory, a fab in industry terms, a facility that turns raw silicon wafers into the processors running every phone, car, and data center on Earth.
Demand has never been higher. Governments are throwing subsidies at you to build one. Every device on the planet needs what you're selling, and there's no substitute product waiting in the wings. That is the dream, and it is not entirely wrong. Here's what it doesn't tell you. You can spend $20 billion building the most advanced factory on the planet, get it fully operational, and still watch the entire investment become worthless within a few years. Because the very thing that makes chips valuable, the relentless march to smaller, faster transistors, is also the thing that can turn your finished factory into an expensive dead end overnight. Let's start with what it costs to build one. A leading-edge fab today requires investment exceeding $20 billion, with only $4 to $6 billion of that going toward the physical structure itself. The rest disappears into equipment, and one machine alone, the extreme ultraviolet lithography scanner needed to print the smallest features on a chip, can cost up to $340 million per unit, with a single fab needing several of them alongside hundreds of other tools. A 3-nanometer capable fab specifically runs $15 to $20 billion, and TSMC has invested over $45 billion into a single new facility for its 2-nanometer process. In the United States, the same fab costs roughly twice as much and takes twice as long to build compared to Taiwan because of higher labor costs, slower permitting, and a domestic supply chain that simply doesn't exist at Taiwan's scale yet. Construction itself involves 30 to 40 million work hours, 83,000 tons of steel, and nearly 800,000 cubic yards of concrete. All to build a facility where the actual production floor must maintain fewer than 10 dust particles per cubic meter, because a single speck can ruin a chip, whose features are now smaller than the dust itself. Before you process a single wafer, the clean room alone costs $10,000 to $20,000 per square foot, not because the room is fancy, but because it requires isolated foundations to prevent ground vibration from disrupting nanometer-scale alignment, specialized air filtration removing essentially all particulates, and precise humidity and temperature control to prevent static discharge from destroying circuits mid-process. Add the design side of the equation, where a single chip's non-recurring engineering cost, meaning the design and verification work before manufacturing even starts, can run $400 to $600 million at the most advanced node, and a single mask set used to print the pattern onto the silicon can cost $10 to $20 million on its own. A single design mistake at this stage can waste tens of millions of dollars in fabrication costs before you even discover the error. Here's the trap sitting underneath the entire industry, and it's the reason a technically successful, fully operational fab can still become a financial catastrophe. Chip manufacturing follows a relentless technology curve. Every few years, a new, smaller node becomes the industry standard, and customers who need the smallest, fastest, most power-efficient chips migrate to whoever offers it. If your $20 billion fab is optimized for last generation's node, you're not competing on quality. You're competing on being obsolete slightly less quickly than your rivals. And once a fab is built for a specific node, retrofitting it for the next one is often more expensive than building an entirely new facility from scratch, because the equipment, the clean room specifications, and the process chemistry are frequently node-specific and don't simply upgrade with a software patch. Once a fab is running and competitive, the revenue model is genuinely extraordinary, which is exactly why governments and investors keep pouring money into it. The core layer is per wafer manufacturing revenue, charged to fabless companies like Apple and NVIDIA who design chips but don't own factories, paying foundries like TSMC to actually produce them. A single advanced wafer can cost the customer well over $20,000 at the cutting edge. And by pooling orders from dozens of chip designers, a foundry achieves the volume needed to justify its enormous fixed costs. The same logic that makes an airport or a mall profitable once enough tenants share the overhead. Depreciation, meaning the amortized cost of that $20 billion facility, gets folded into the price of every wafer, sometimes adding up to $5,000 per wafer on its own. And because switching foundries is genuinely difficult once a customer's chip design is locked to a specific manufacturing process, a fab that wins early access to a major customer often keeps that customer's business for years, generating a recurring high-margin revenue stream that barely needs to be resold each cycle. Now, the disaster case study. And it's a lesson in exactly how fast the technology curve can strand a serious competitor. GlobalFoundries, spun out of AMD's own manufacturing arm, spent years developing a next-generation 7-nanometer process, going so far as to install at least one EUV lithography machine, an extremely delicate and extraordinarily expensive piece of equipment, at its Fab 8 facility in New York. Company executives publicly stated 7-nanometer chips would be in limited production by the end of 2018. Then, in August 2018, GlobalFoundries abruptly halted the entire program indefinitely. The reasoning wasn't technical failure. It was math. Ramping up the 40,000 to 50,000 wafers a month of capacity needed to have any realistic chance of profitability at 7-nanometer would have cost another $2 to $4 billion on top of what had already been spent. And the company's existing 14-nanometer fab was already running at full capacity, meeting current demand, meaning there was no easy way to free up capacity for the new node without cannibalizing a business that was actually working. Worse, GlobalFoundries' primary advanced node customer, AMD, had already begun shifting its most demanding chip designs to TSMC, which had made the multi-billion-dollar bet on 7-nanometer that GlobalFoundries was now abandoning. The decision to withdraw led to layoffs affecting roughly 900 employees and permanently relegated GlobalFoundries from the leading edge of chip manufacturing, ceding that ground to just 3 global players: TSMC, Samsung, and Intel. Years of R&D investment and a functioning EUV installation were shelved, not because the technology didn't work, but because the fab couldn't justify the additional billions required to compete at a node where its biggest customer had already walked out the door. Let's run the numbers on 2 scenarios. Optimistic case, you build a $20 billion advanced fab, secure long-term supply agreements with 2 or 3 major fabless customers before construction even finishes, guaranteeing enough wafer volume to hit full utilization within 2 years of opening. At roughly $20,000 per wafer and 50,000 wafers a month once ramped, that's $12 billion in annual revenue against operating costs, materials, utilities, and staffing of roughly $6 billion, leaving a genuinely strong $6 billion annual margin, precisely the economics that let TSMC justify continually reinvesting tens of billions into its next facility. Realistic case? The same $20 billion fab built for a node that becomes obsolete faster than projected, or built without the guaranteed anchor customers locked in ahead of time. Your primary customer, facing better pricing or better performance elsewhere, migrates its next chip generation to a competing foundry. Exactly what happened to GlobalFoundries with AMD. Utilization falls well short of the volume needed to cover your fixed depreciation costs, and the fab that cost $20 billion to build
now generates a fraction of the revenue needed to justify the next node's $20 billion investment, permanently locking you out of the leading edge and relegating your factory to legacy, lower-margin chip production for the rest of its operating life.
So if you decide to own a chip factory, understand what you're actually buying. You're not buying a factory that makes a durable product you can sell for years without changing it. You're buying a perpetual, multi-billion-dollar bet that you can stay on the cutting edge of a technology curve that obsoletes itself every few years, with customers who will leave the instant a competitor's node is smaller or cheaper. Win that bet consistently, and you own one of the most valuable, defensible businesses on the planet. Lose it once, the way GlobalFoundries did, and you can spend billions building the future and still end up manufacturing yesterday's chips for the rest of your company's life.